Hello everyone. Today we'll discuss two identities on class 11 trigonometric solutions from ML Agarwal. Given sin 4 alpha by a plus cos 4 alpha by b equals to 1 by a plus b. You have to prove sin to the power 8 alpha by a cube plus cos to the power 8 alpha by b cube equals to 1 upon a plus b whole cube. Given sin to the power 4 alpha by a plus cos to the power 4 alpha by b equals to 1 upon a plus b. So we can write this one as sin to the power 4 alpha by a plus 1 minus sin square alpha whole square by b equals to 1 by a plus b. Taking LCM, this one cross multiplied, b into sin 4 alpha plus a into this whole square can be expressed as 1 minus 2 sin square alpha plus sin 4 alpha whole divided by a into b equals to 1 upon a plus b. Thereafter we can write, taking sin 4 alpha as common from both the ends, a plus b into sin 4 alpha minus 2 into a sin square alpha plus a by a into b equals to 1 by a plus b. Thereafter we can write, taking cross multiplication, a plus b whole square into sin 4 alpha plus 2 into a plus b into sin square alpha plus a into a plus b equals to a into b. Thereafter we can write a plus b whole square sin 4 alpha minus 2 into a plus b into sin square alpha plus a square, as a into b from both the sides are cancelled, plus a square. Taking this one as perfect square, a plus b into sin square alpha whole square minus 2 into a plus b into sin square alpha into a from b position plus a whole square equals to 0. So sin square alpha into a plus b minus a whole square equals to 0. So sin square alpha is equal to a by a plus b. Thereafter we can write cos square alpha is equal to 1 minus sin square alpha. So 1 minus a by a plus b, it will become b by a plus b. Hence we have to prove sin to the power 8 alpha by a cube plus cos to the power 8 alpha by b cube, this one. Thereafter we can write 1 by a cube into sin 8 alpha, the value of sin to the power 8 alpha. Sin square alpha is a by a to a plus b, so sin to the power 8 alpha becomes a by a plus b whole to the power 4. Similarly, plus 1 by b cube from here, 1 by b cube into b by a plus b whole to the power 4 from cos square alpha. Here it is b by a plus b whole to the power 4. Taking cancelled a cube and a cube, remaining part a by a plus b raised 4 plus b by a plus b raised 4. This one, a by a plus b raised 4 plus b by a plus b raised 4 equals to 1 by a plus b whole cube, as we have to prove. Here it is proved. Now question number 2, given tan beta is equal to tan alpha plus tan gamma. Tan alpha plus tan gamma divided by 1 plus tan alpha into tan gamma. Prove that sin 2 beta is equal to sin 2 alpha plus sin 2 gamma divided by 1 plus sin 2 alpha into sin 2 gamma. So given tan beta is equal to tan alpha plus tan gamma divided by 1 plus tan alpha into tan gamma. So tan beta equals to sin alpha by cos alpha plus sin gamma by cos gamma whole divided by 1 plus sin alpha by cos alpha into sin gamma by cos gamma. Taking LCM from the numerator and the denominator, it will become sin alpha cos gamma plus sin gamma into cos alpha whole divided by cos alpha cos gamma plus sin alpha sin gamma, and the numerator entirely common as well as cancelled. So here it will be sin of alpha plus gamma at the numerator whole divided by cos of alpha minus gamma at the denominator. Thereafter sin 2 beta, as we know, sin 2 beta equals to 2 tan beta divided by 1 plus tan square beta. Putting the value of tan beta from here, 2 into sin of alpha plus gamma whole divided by cos of alpha minus gamma whole divided by 1 plus sin of alpha plus gamma by cos of alpha minus gamma whole square. So it will be 2 into sin into alpha plus gamma into cos of alpha minus gamma whole divided by cos square alpha minus gamma plus sin square alpha plus gamma. Here it will be by the formula of addition and multiplication. Sine of alpha plus gamma plus alpha minus gamma plus sine of alpha plus gamma minus of alpha minus gamma. That will be sine of 2 alpha plus sine of 2 beta. As we know, 2 sine c into cos d, sine of c plus d plus sine of c minus d. And here cos square alpha minus gamma, we can write it as 1 minus sine square alpha minus gamma plus sine square plus alpha gamma as it was. So sine 2 alpha plus sine 2 gamma at the numerator divided by 1 plus, shifted this one, sine square alpha plus gamma minus sine square alpha minus gamma. Here it will be sine 2 alpha plus sine 2 gamma, 1 plus, it will become sine 2 alpha into sine 2 gamma as the formula this one. Here it is put. Thank you everyone. This is all for today. Thank you. See you again for the next video.